We're going to find the derivative of this function here, and this is another chain rule problem. But first we have to remember our rules for exponents. A fifth root can be thought of as a 1/5 power. And then you'll notice that we have a function inside of another function. We have this 5x over 5x minus 4 function that is then being raised to the 1/5 power. So if you wanted to, you could say that u is 5x over 5x minus 4, and you could say that f of u is u to the 1/5, but I'm just going to skip that notation and take the derivative. The derivative of this function with respect to x starts with the outermost function. We have something being raised to the 1/5 power. So the power rule says that we can take that 1/5 power, move it out in front of the function, and then subtract 1 from that power. What happens when you take 1/5 and subtract 1? Well, you get negative 4/5. But our derivative isn't finished yet. The chain rule says that anytime we have a composite function, or a function inside of another function, we have to then take the derivative of the function that was inside. So how do we find this derivative right here? Well, it looks like a quotient of two functions, so we're going to use the quotient rule. And the quotient rule says we need to take the bottom function and multiply that by the derivative of the top function, and then subtract and take the top function and multiply that by the derivative of the bottom function, and divide that whole thing by the denominator squared. So let's take the derivative of 5x. We get 5, and the derivative of 5x minus 4 is also 5. Now we can simplify this numerator by multiplying the 5's through the parentheses. You'll notice that the 25x's on top cancel, and we end up getting that this derivative right here is just negative 20 over 5x minus 4 squared. Now we have a lot of things that look like they might cancel in this derivative, but note that this 1/5 and this 5 don't cancel because this 5 is being raised to the negative 4/5 power. So that 5 and that 5 are not the same number. And there is a way to combine this 5x minus 4 with this 5x minus 4, but we have to notice that this 5x minus 4 is being raised to the negative 4/5 power. One thing that we can do is cancel this 1/5 with this 20 over here. That would leave us just with a negative 4 on top. So let's do that first. Alright, we have a negative 4 out in front. This 5x is being raised to the negative 4/5 power. This 5x minus 4 is being raised to the negative 4/5 power. And this 5x minus 4 is just going to stay here. Okay, this is starting to look a little bit messy, so I'm going to create a little bit of space here. And I'm going to remind you that a negative exponent can be sent from the numerator to the denominator and vice versa. So we can rewrite this term like this. Now we can certainly move some terms around to make this look a little bit clearer. Maybe if we line things up in this way, it's easier to see what's going to happen with the exponent on this 5x minus 4. We have a 4/5 on top and a 2 on bottom. If we subtract those exponents, we're going to end up with a 5x minus 4 to the 4/5 minus 2 power. That's going to be a negative 6/5 power. Now, as far as this term is concerned, I'm just going to leave the negative 4 outside. And you know what? I want everything in my numerator. So I'm going to move this term back up to the numerator and call it 5x to the negative 4/5 power. Of course, there are several ways that we can write this answer, but I kind of like it all in one line like that. So I'm going to leave it like this, and we're going to call this problem good. I'm going to zoom out on the thing so you can see all of the work that we did, and I'll see you in the next calculus problem of the day.